Hi guys, it's a video time again. Took me quite a while to make this video because I had problems with my health. I don't know, perhaps you still hear it. I had a nasty flu, the real flu. And even that though I had time to make videos, I didn't have the mood to do it. I don't know, I was only tired and all this stuff. Anyway, today it's the continuation of the RF Voodoo microwave magic. It is everything about Klystrons. Last video was about magnetrons. I showed you from my collection some magnetrons that I have. This time I want to show you some Soviet Klystrons and Western Klystrons. But what's the most important question is what's the difference between a Klystron and a magnetron? Well, a magnetron is just nothing else as a giant microwave generator, power generator. A Klystron is a linear device. That means that can amplify signals, has an input and an output. And of course, it can be used as a generator too. But yeah, most of the time it's used to amplify high frequency signals. For example, as I wrote together here, it's used for amplify high radio frequencies from UHF up to the microwaves. I'll let you read that. The most important names in when you speak about Klystrons is Varians. Brother Varians invented the Klystrons, more or less, yeah. And they made them commercial. They found a company called Varian. Here you see a little bit more. The Klystron is one of the oldest microwave generating and amplifying devices. And in the Second World War, the Axis forces, that means Germany and Italy, were using Klystrons for radars, and the Allies were using, like the British and the Americans were using magnetrons for radars. You will see that some of the Klystrons that I have here are US made during the war, and they have a very similar one made in Germany. This is because somehow these Klystrons were either from planes that shut down, and the Germans found them and reproduced them, re-engineered them. Another interesting thing is that after the war, in the United States, a network was developed called long lines. It was a network of many stations, thousands of stations that were connected through microwave links. And at that time, for these microwave links, Klystrons were used. This microwave links, these long lines, the intention was that in case of a nuclear attack, these communication lines will survive. Because, as we know, solid state stuff will get fried with EMC, and this Klystron based communications was thought that it will survive. There are still some of them in use, or at least they exist, as you can see here. Anyway, this is a little bit more information. And these are some of the reflex Klystrons, how they look. And yeah, this video is not intended for theory. how it works. This will be in the links. I will provide links to videos on the functionality of the Klystron. I just want to show you how weird many of these devices look. And this is why it's called Voodoo and microwave magic. So let's continue. For the beginning, I will start with Soviet era Klystrons. As you can see, this one, the documentation is from February 1988. This is a very, here you see, long time ago, not long time ago, for quite a while, I thought that OTK means that it's a military grade. But no, it's not. It seems that it is just a quality stamp, nothing else, but the military sign is the rhombus here. Two viewers gave me this information, and I want to thank you for them. So it seems that this rhombus, where you can see it, means that this thing is military grade equipment. Look at this documentation, yeah. Okay, this is how they draw it. I just want to show you how funny this is, all what you get, yeah, with this Klystron. And it comes like that in there. Put insert like that. So that's the Klystron. This is how it comes, protected. Let's take it out. It's a K-187A. It's a reflex Klystron. It's one of the more unspectacular ones. Here you have the cavity, and this is how it looks. As I said, not very spectacular, but when you get something like that in your hands, you know it's not a piece of plumbing equipment or a valve or something. It is a Klystron. Again, you have the military marking here. It's completely new old stock. And as we know, 1988, it was at the end of the Soviet Empire, let's say so. It was one of the last ones probably that have been built. I think that the two yellow ones, I have to check it, are the heater. Then you have the cathode, grid, anode, and the cavity. Here you have the fine-tuning screw. I don't know if I can remove that without, yeah. Well, this is how it looks. This is where it will be connected to a cavity line. The K-187, for example, is one of the kind of reflex Klystrons that were used as a local oscillator. This is why it has more or less only an output cavity. There's a little bit more information about it. And here you see the frequency. It's a wide range, 16.6 gigahertz to almost 40 gigahertz, and an output power of 11 milliwatts. 6.3 volt heater. forced air cooling. This is all the informations I have from this kind of Klystron. Next one I want to show you is a Western Electric one. That's an US one. Look at how old this thing is. This thing is built somewhere beginning in the 40s, in the middle of the war. Comes with that original box, Western Electric. It has some writing here, US Army Signal Corps. It doesn't say from when it is, or at least I cannot find it out. 44, I'm not sure about that, perhaps. But this thing is really old. This is one that is, I don't know, I can say a classic design of a Klystron. How I see many other Klystrons after these ones were built. Yeah. I show you later that the datasheet of, or a datasheet of the B and B version of that. There is the series of 3 of them, the ABC. The only difference is in the frequency, nothing else. It has been said that this particular model, not this one, this particular model was probably either in a plane or, I don't know, in a boat or something that was fighting in Germany or over Germany, was shot down, was captured, and based on this design, the German made one of their own, an LD-27 called LD-27, that it looks very similar, quite like that. But this happened very soon after this came out. This is a little bit different because it has an octal socket. This octal socket is so old and you don't have a cavity or anything. This is the output here. And this mechanical thing here is for changing the frequency, for fine tuning. As you see, very old one, beginning of the war, 1940s something. From a time that there was still no JAN, Joint Army Navy, on it. This come later. This is how the older 726 one looks. This is a classic look of a Klystron, for me at least. And this is the one, what I said, it is probably one that this kind of Klystron was either flying with over the German skies and was shot down the plane, and German found that and re-engineered that, because after that a German Klystron came out called the LD-27 that looks exactly like that. Yeah, it is built, as I said, during the war. Frequency 3.2 gigahertz to 3.4 gigahertz. For the A-type, I don't have an official datasheet, but from the series, there are 3 ones, A, B, C. The only difference is the frequency range. Here you can see the datasheet, one of the datasheets for the 726 Western Electric. It's built from Western Electric. As I said, the only The only difference is the frequency. This one too was used as a oscillator, and the output power 110 milliwatts, sorry. It's very old. And here you have a little bit more information about it, the mechanical informations. Here we have a Soviet one again. Don't know if you can see it correctly. It's very difficult to see the writing on it. It's called K26. It's from 1989. It's again a reflex klystron. It has, like the American ones, the octal socket. Here we see again the rhombus. That, from what I've been said, is the marking for the military grade parts. Again, this is made, this one is made at the end of the Soviet era. It's very difficult to read because here's the getter, K26, and the OTK reading. I will show you a data sheet. Yeah, this is what I have as a data sheet. It's just a combination of information that I gathered. It has an output of 80 milliwatts. It's a low frequency reflex klystron, 500 to 700 megahertz. And some pictures here where you can see better how it looks. You see how interesting and weird some of these devices look. This, for example, these discs here, this connect to the cavity. The last Soviet one, not Soviet, but from the Soviet bloc that I have, is this one. It came in this box. It's called MR01. I have no clue from when it is. There are not many informations about that. I have no real data sheet except of a few pieces of paper that you will see that are inside. Before I show it to you, it looks like a bullet. I have this documentation. This one looks original. And it's written in Hungarian. I don't know if somebody can read it. It seems to be from 1979, I think. Probably the frequency of the test frequencies of the Klystron, the voltages. Then there is a second one, slightly different data. And interesting, and we have one that is newer, it says at least 1983. That has some other information that I cannot read. Anyway, it seems it's from 1979, it's Cold War era, but Look at this thing. It looks like a bullet. A very interesting one. It is from Klystrons, a Hungarian company. Was in the 50s, 60s very well known. Let's take a look how it looks inside with the getter. For me, no markings that say that this is a military grade anything. It has a hole, but no threads. It really looks like a bullet, like a ceramic base. As you will see that in the little documentation that I have, that I will show you, the name is not Klystron, it's another Hungarian company that I don't know which come first. I think Klystron is later than the other one, Vectra, I don't know, you will see what I mean. When I first found that, I had no clue what that is. Yeah. There are not many informations about it. But this is how it looks. Like a bullet. Small one. I don't even know what the power is that this one has. This is all the information that I have from this MR01 Klystron. That's an external cavity reflex Klystron, and look at that. What I found is from another company called Vatek, Budapest. Klystron is from Budapest too. So I believe that Vatek was the original manufacturer and either was renamed Klystron or was bought from Klystron. I don't know. This is how it looks. It's a weird design. Yeah. This design like a bullet, like a small rocket. Fortunately, not much information except of these pieces of paper that I've shown you. And now, two classic ones. Classic Klystrons, from the look of it. Look at this one. This is an original variant, the VA222A. This is the cooling part, and this is the waveguide connection part. I will show you the details of the datasheet later. Again, the base is an octal base. But this is how most of the Klystrons, the low power Klystrons I know, look. In different colors, of course, but variant was this red color. This seems to be made as aluminium because of the weight. It is a lightweight one. Here you have the screw for fine-tuning the frequency. I don't know if this one was for commercial or military use, but it still says no. Jan, Joint Army Navy. This one is the American-made one. You see here, this is the cooling part. It is, I'm sure, made of some aluminum alloy. Exactly near to that, and much heavier, much heavier, it is the European counterpart from Thomson CCF. This one is made in Europe, in France. It looks more or less similar. The only big difference is that this part here, the cooling part, is fully made of copper. This is the reason of the weight difference. This thing is almost double the weight of the Varian one. Otherwise, it's exactly the same data, the same size, same everything. Just to show you exact the same types of a Klystron, left US made, right European made, and much robust and much heavier. This thing is a lot heavier, and of course the cooling is much better because it's made of copper. Looks like a fire truck. Again, I do not have many or exact data sheet. I only have this Varian catalog from 1961, where the 221 and the 222 is included, and you see it is from between 5.9 gigahertz to 8.1 gigahertz. And what it says here, for microwave relay transmitters, conduction code. That means that probably one of those was used in the long lines network in the United States that I showed you at the beginning of the video. What do you say about this thing? What is that? When I first received it, among other stuff in a lot, honestly I wasn't sure what that is. It looks like a pressure transducer or something, yeah? But I found out that, again, it is a Klystron. Varian had made this weird looking ones with a different color, blue mostly. Here you see this screw for fine-tuning, a 3-pin base, and the cavity connection with a glass protection here. I have absolutely no data about that. I can show you only similar ones that are probably very close to the one I have. Let me show you what I mean. It's quite old one, quite used one, quite abused one probably. Oh, there's a writing here, 8R something. I didn't find anything based on the markings, but I'll show you a similar datasheet. This is the one I mean. This is a datasheet from Varian. It looks very similar. No clue if the frequency range is similar to, but at least we know that the output is 125 milliwatts. It is quite powerful. The rest, curves and a little bit more information. Here you can see the heater, cathode, 2 heater contacts and the cathode. tuning shaft, etc. That's all what I have for this Klystron. It's a weird one, but the weirdest one I leave for last. You see, it's 1955. No clue if the one that I have is earlier or same or later. Well, I have one left for last because for me this one is the more weird one, not this one that I showed you before. Look at that. UFO, or looks like the head of the Mandalorian with the antenna, or like the robot from Lost in Space. Warning, Will Robinson, warning, warning. When I saw this one, I had to have it. It looks so good, so interesting. Here you see dedicated, you don't have waveguide connections, you have connections directly, coaxial connections for connectors. Look at that, how weird this construction is. This is some kind of lever that you can release and lock, input and output, the anode. And this one has JAN written on it. That means Joint Army Navy. That's 50s, 60s. JAN 417C. Again, not very, I don't have much information about it. It's made by Sperry and has an octal base. By the way, if you like what I'm showing to you, warning, warning. If you like my videos, smash the like button. Please subscribe to my channel and ring the bell, push the bell button. All this helps my channel to grow and me to be able to show you more about this weird and interesting thing. And as I said, I have a lot more about weird and funny looking tubes and RF equipment. Let me show you the little what I have on information about this one. Again, I'm showing to you because I like it. I really like it. I bought it on eBay just for my collection. Here you can see a little bit, some more information on pictures about this 417 Klystron series A, B, and C. There are blue ones too. And honestly, I like them more. I hope I can find one for my collection. I'm just showing you, you can read it. It's a very low frequency Klystron, 2.6 to 3.3 gigahertz, but for now, the one with the most output power, 250 milliwatts, was made by Sperry and Westinghouse. And just a little bit more information. These are original data sheets. This one is from March 1970. A military specifications sheet for the 2K41 that is built exactly the same as the 417C or A. Further down you will see what I mean. This is how they look. Again, for me this is one of the weirdest ones. The way that it's built, as I said, warning, with Robinson warning. Danger. Okay guys, that's it. I hope you liked this video. It was a relatively light video for the beginning after my illness. Please subscribe and press the like button. Cheers and see you next time. Bye.